How many people think that I should do example number 7, or is it pretty easy?
Is it?
Well, let's look at it. Kitty O'Neill, a female drag. Didn't you do this one already? This is the one you did, right? This one was easy, right? It's a straightforward. You've got an initial velocity. Oh no, initial velocity is 0. The final is 628. The time is 3.72, and you're solving for g. The only thing you have to do is divide by 3.6, right? And then it's a straightforward application of d equals, oh no, how do we do this one? It's in seconds. You got to convert to meters per second. We want to know how far, right?
So why would you be?
Well, we don't have the acceleration, do we? So we got to solve for that, right?
Why would you be dividing it? It's like the weird thing. Wouldn't it be like more seconds? So
But much smaller units, right? Kilometers per hour to meters per second is divided by
and so
3.6.
when you multiply it, it's seconds.
It's meters per second to kilometers per hour. Yes. So we're going to go VF equals VI plus AT, and then we're going to go, I think, D equals VIT plus 1/2 AT squared, right? And I did that on like Thursday, didn't I already?
I don't think we actually did.
Or maybe, should I do it? Like, do you want me to finish it? Okay. Let's do it for completion's sake. Let me grab a second. Let's just do it so that we can say that we've done it all and I haven't left you hanging. Okay, so first step is to do that, divide by 3.6. So 628 divided by 3.6 is 174.4. Now I'm going to go 174.4 is 0 plus 8. T is 3.72. And you get a time of 46.9. Is that right? No, not T. That's A, isn't it? We're solving for A. Now plug that in over here. Initial velocity is 0. So that is going to be divided by 2 and then times by 3.72 squared. I get 324.5 meters. Let me just check my notes here. Yeah. That's a pretty standard, straightforward. I guess it's a 3-step question because of the divide by 3.6, right?
Isn't it like VIT plus?
Yep. But the initial velocity is 0, right? So
Yeah. Oh,
0, yeah.
Okay.
So would you mark that as like a 3-mark question?
I would probably give you 3 marks, yeah. And generally, Steve, I do those, like, should you really get a mark for the divide by 3.6? Well, again, I try and make the test out of as much as possible because any mistake then becomes magnified, right? So there's always going to be those easy marks. What would happen if you didn't do that part? Well, you'd get 2 out of 3, right? Okay, let's skip to example 8. Are we all good?
Yeah.
Okay, what do we know here in 8? We have initial velocity of 20, final velocity of 230. There's our time. Is this one any different than 7?
No.
There's no difference in the steps. The only difference is the initial velocity is not 20, right?
Yeah.
That's the only difference. Steps are exactly the same. Do you want to just try it?
Sure.
Do you want me to just write it out? You try it. I'm going to write it. I don't think I need to explain it. For the sake of completion, I will write it out here for you. I did that already. Yes, I divided by 3.6. I probably wouldn't give you a mark for each one of those. I'd probably only give a half because really you do.
It's meters per second, right?
You're changing to meters per second, right, you are. And I'm going to do a bit of a mathematical jump here, and I'm assuming you guys can do that. You'll know the steps that are happening there. If you're not sure, feel free to ask.
So would you be expecting us, do you want us to show every step,
No, like I'm good with this.
as long as it makes sense?
Yep. I think you need to sort of start consolidating your math and sort of expanding that, and I'm assuming that you can sort of make some of those 2 and 3 step, you can see them kind of happening. And if you're still struggling with that, I'm more than happy to go through that with you. But do try to challenge yourself with it. I get 260.8. We are going to solve Fred and Barney today, by the way.
Oh, that's like a tough one.
It is.
I couldn't figure it out.
I'm gonna help you. Okay, here's a little bit of a challenging one. We're trying to find the acceleration. It deploys in 30 milliseconds, so you got to convert that to seconds. Milli means thousand, not milliken, thousand. So we're going to divide by 1,000, so that's 0.03. And the distance is 40 centimeters. D is 0.4. So really, this one's more about changing
So it's only, wouldn't it be one more zero or no?
milliseconds, 30 milliseconds. So 30 divided by 1,000 is move 3, right? 1, 2,
Okay.
3.
And like 100 like centimeters is a meter.
How many is that?
100 centimeters. So that's going to be 40 divided by 100, right? Decimal 4. So once you've got that, it's just a matter of going d equals dit plus 1/2 at squared. 0.4, what's the initial velocity? 0. But if the airbag's going off, isn't the car traveling some speed? Like, isn't that the initial velocity?
Yeah.
The airbag is at rest relative to everything else inside the vehicle, right? Like, so this distance of 0.4 is the distance that it comes out, even though it's moving at a high rate of speed forward.
Sorry.
And so are you, exactly. Everything inside the car is moving, we're just basically assuming it's at rest. So that's 0. 1/2 a, this is going to be 0.03 squared. I'm going to show the math steps here, just for people to make sure that they get it. So this is going to be 0.03 squared is going to be, that's going to be 0.0009, I think, right? Divided by 2 and a. So we got 2 times 0.4 all over 0.0009. I get 888.9 meters per second squared. Does that seem reasonable?
Where?
Well, times.
Just multiply.
Could you want to do times it by a half, or do half it divided by 2?
Same thing.
It just scares me.
Times it by a half and dividing by 2 are the same thing. If you're struggling with the arithmetic, the math, please be sure to ask. I see a few faces there that I'm making mental notes. I have to go by and talk to them. If you want to send me a message saying, I need some help there, Mr. Bennett, I'll be happy to do that. I'm kind of speeding up a little bit because I want to make sure I get to Fred and Bernie. What time are you leaving, Jessica? 250? Okay, you're not going to get to February. You'll have to watch it online.
Um,
Okay, number 11. Are we good?
Yeah, I get it. I just come up with that. What were we trying to find?
There you were trying to find the acceleration.
What do you got? So would it have been 88?
I get 888.
Yeah. Would it have been wrong if, like, 0.03 squared, that's 0.009.
Yeah.
Would it have been wrong to just 0.4 divided by that number, and then divide it again by half?
Yeah, that would work too.
Okay.
Okay, Jane Bond runs down the sidewalk, accelerating uniformly at a rate of 0.2 meters per second squared from her initial velocity of 3. How long will it take Jane to travel the distance of 12 meters? I need to show you this one for a very good reason, which you're going to find out right away. We have an acceleration of 0.2. We have an initial velocity of 3. We know the distance is 12, and we are looking for the time, right?
Yes.
V equals VIT plus 1/2 AT squared. What is the distance traveled? 12. What is the initial velocity? 3 times t plus 1/2 the acceleration is 0.2 t squared. Now, are you getting nervous?
Nope.
Do you know what's coming?
No.
Do you know what's coming, Tatiana? No? You will in a second.
Quadratic form.
Yep, that's it. Move everything to the right-hand side. Half of 0.2 is 0.1 t squared. 0.1 t squared plus 3t minus 12. We have ourselves a quadratic situation. I'll pause there and wait for the applause and the cheering to die down. No? Yeah.
how did even, what did you do with the last steps? I don't know.
What did I do here? I took the 12 to the other side,
Yeah.
became negative,
Oh, and then you,
and then I just put them in the proper order, the t squared t and no t order.
what happened to the 1/2?
1/2 times 0.2 is 0.1.
I'm just
Oh,
combining them.
well,
Yeah.
Are you sure this isn't factorable?
oh, it's 0.1.
Well, it might be.
That makes sense.
What's one way we could try it? No one wants 0.1 out front there and factoring that, right? That's sucky. What you could do is you could multiply everything by 10 and get 0.1 times 10 is
T squared.
t squared plus 30t minus 120. Is that okay? Yes, we multiplied both sides by 10. Now I got to factor that. Factors of 120 that add or subtract up to 30.
16, 20 would be the only one in.
16, 20, or 40, my friend.
I was thinking back to 12, 6, and 2. That big only thing in the relative possibility that'll get you 3, but it doesn't work.
So in other words, it probably exists, but are you going to be able to find it or come up with it? It's probably some decimal value, right? Really what we're asking you to do is we're asking you to graph 0.1 t squared plus 3t minus 12. I guess that's going to be a positive, so it's going to be facing up, right? It's going to be kind of like that, isn't it, right? And we're asked to find those zeros, right? But because in the world of physics, and the x here is the t, does time exist in the negative? So none of that even exists. So it's just really finding this 1 0 here. So, quadratic formula, probably everyone's got it memorized by now.
Negative b plus 2, negative b plus or minus 2, or AC equals.
You never see this question come up on Pawn Stars, on Pawnography or Trivia Crack. I'm going to start, what I'm going to start doing, I'm going to start adding in physics questions on Trivia Crack.
What category?
Nerds.
Art? Business science?
Yeah, I'm going to throw them into art.
No one did
Can you do that?
Who goes art for? Art and art and history.
I generally clean up on that game. Yeah. Okay, so some people may not be familiar with the quadratic formula. It's minus b plus or minus the square root of b squared minus 4ac all over 2a. Just memorize it. It comes from this. Ax squared plus bx plus c. When you've got a quadratic equation, the number in front of the x squared is the a, and the number in front of the x is the b, and the number all by itself is the c. Is that coming back to some of you now? Give me the nod. Riley? Yeah? Okay. John? Yeah? Okay, good. Okay, so in this case here, it's going to be x equals minus b is going to be negative 30.
Why would you have to do the 30? Wouldn't you just stay with the initial one you had? Yeah.
Oh, yeah, sorry. Yeah, let's do the 3. Yeah. No. Yeah, sorry.
Okay, cool.
3. Would it work? Would either one work?
Yeah.
Absolutely.
Would you have to divide after to get the real answer, or no?
Negative 30.
You know what? We'll find out right away. Negative 3, yes. Someone's yelling at me. Negative 3. Plus or minus square root b squared is going to be 3 squared minus 4 times a is 0.1 and c is negative 12. Does anyone happen to know what's the name of the number that's under the square root sign? Did they teach that in math class still? What's the name of it?
Oh, the...
Starts with a D. Discriminant. Is that taught?
I think that's more about grade.
No, it's for 11.
I don't know.
Okay, whatever. You don't need to know it. But I will tell you that something happened. What happens when the discriminant is negative?
Doesn't work.
No answer, right? So here I've got 3 squared is 9. I'll tell you that it's the square root of 3.7.
Wouldn't you want t equals on the outside?
Oh, yeah.
What?
Can I put it in red, Steve, for...
Sure.
Oh, I get it.
Yeah, it's t, right, in this situation. Now, remember, we don't need to find the negative value. If you want to find them both, you're going to find that x is equal to 3.5 seconds or minus 33.5 seconds. I took the square root already, yeah. What do you mean?
No, and not
In
about the
math.
other.
They don't let you show go from there to there?
Well, because we can only square root it if it's a perfect square. Because we don't get calculators for now.
Oh. Hannah's asking about the negative 33.5. That is this 0 over here that doesn't exist in the physics world. Okay? Now, you can try to figure out which, because you either add or subtract, right? So if this is positive down here, to get the positive value on the top, right? If this is positive, then the top has to be positive. And the only way for the top to be positive is if we go minus 3 plus 3.7, right?
Can I just say it's 3.5?
Yeah.
Because I'm not going to
What was your number?
Scary stuff.
After the brackets?
What was my number after the brackets?
Or I mean, sorry, after the square root.
Well, it's going to be whatever 30.7 squared is, isn't it?
Oh, the freaking video. That's the bio video from like,
I'm like really
We've all watched that like 20 times, I swear to God.
Are you getting the wrong number? Yeah.
Okay, so it's 3. Well, let's do it. 3 squared. I'll do more steps.
Oh, I multiplied 9. Oh, no, yeah, you're supposed to.
Like that?
Oh, I subtract.
Okay. Now, excellent point. If you make a mistake in here, I'm going to follow it through and try to find it, right? So show your work, and I will tell you that you're going to need this stuff when we get to projectile motion. Quadratic formula is used more often than you want to. All right. You probably couldn't sleep over the weekend because you wanted to know the answer to the Fred and Barney question and you couldn't solve it.
Oh, the
I know I tossed and turned worried about you. Let's have a look at it. Several people, final answer to that one was 3.5. Okay, let's solve Fred and Barney, and then I'm going to give you a chance to do the last one. Fred and Barney are at opposite ends of a 1 kilometer long drag strip in their matching race cars. This is the one that you guys did in the big paper. No. Fred accelerates from rest toward Barney at a constant 2. We'll call this Fred over here. We'll call this Barney over here. He has an acceleration of 2. Barney's traveling toward Fred at a constant speed of 10. So he has an initial velocity of how much?
Yeah. Negative 10.
Why negative? Because he's going left. Is that important in this question? Yes. So the acceleration is positive. Here the initial velocity is minus 10. How much time elapses until they collide? So we know that there is some sort of collision happening somewhere in here. Is it at the 500 meter mark? Good chance no.
One car's probably going faster.
Yeah, because Fred's going to be going, like, he's going to be going 0, 2, 4, 6, 8, 10, 12, 14. He's speeding up real quick.
He's just going slow and steady.
Yeah, exactly. Wow. Okay.
Or both.
Here's the key idea. The crash occurs when not the times are the same, positions are the same. When they are in the same position at the same time, that's going to be a problem. Right?
Yeah.
Okay, so I highly recommend you label one end, and I like to go with the left end as 0, and the right end at plus 1,000. So Fred's initial position is at 0. Fred's over here on the left. And Barney's initial position is at plus 1,000. Now, position Fred is equal to 0 plus displacement Fred, DISPF. Position Fred is equal to 0 plus displacement Fred. Position Barney is what?
1,000 plus displacement. Isn't the displacement going to be negative?
Excellent. Good. Most of the time I go 1,000 minus the displacement, but I've realized that Steve's right. The displacement is negative. Really? So I should really write, if you're going to be technical, it should be 1,000 plus displacement Barney, that's DISPB, keeping in mind that the displacement's going to be negative. And those two things, when they are equal, is when the collision occurs. So now we got to come up with some sort of formula for this one, and some sort of formula for this one, right? And make them equal to each other. So this says, this is terrible. Can I redo this? Do you want me to redo that?
Yeah.
That's pretty bad, isn't it? It's pretty close. Position Fred is equal to 0 plus the displacement of Fred, right? That's pretty good handwriting recognition, isn't it? If it can recognize my handwriting. Yeah, that one's not going to come up, right? Oh, what's going on there?
Mr. Bennett, how'd you feel with Saturday night?
Felt pretty good, eh? I mean, they did beat a minor league team, mind you, but
I felt great. I was pretty confident.
yeah.
It'll be explaining going to the whole skin. That should be somebody.
Wow, it wasn't going to last forever. Okay, is that better? Okay, so what then is position Fred? PF is 0 plus. Now the displacement of Fred, he's accelerating, right?
Yes.
What's the formula for displacement that has acceleration in it? D equals VIT plus 1/2 AT squared, right? So position Fred is equal to, he's got an initial position of 0. What's his initial velocity? Also 0. So it's really just 1/2 his acceleration, which is 2t squared, which conveniently works out to just plain old t squared.
Is that for the first one? Is it 0t or is it 0 plus?
It's 0 plus, yeah. Right? Fred's position is position 0 plus his displacement, which is VIT plus 1/2 AT squared, and his initial velocity is also 0, so I got 2 zeros plus 1/2 AT squared, 1/2, the acceleration is 2, it's just t squared. Let's do the same thing with Barney. PB, position Barney, 1,000. Now, because he's moving at a constant velocity, what's the formula for the displacement that includes constant velocity? You've seen it in grade 9. Is it not just, in grade 11, is it not just V bar T? Come on, right? V bar equals D over T. D is equal to V times T, constant velocity, right? If you're traveling 20 meters per second for 2 seconds, you're going to go 40 meters. So here I'm going to have 1,000 plus his velocity is minus 10. So really, I'm going to rewrite that. It's 1,000 minus 10t, right? The 10 coming from there. Do you have any idea what the next step is? I'm really stretching your limits today, I know. What's the next step? Any ideas? Remember, the crash occurs when? When their positions are the same. Not the rash. Well, it might be road rash. Crash occurs when their positions are the same. So how do I make their positions the same? Make them the same. Position Fred is equal to position Barney, which is t squared is equal to 1,000 minus 10t. And now what do we got? Stinky old quadratic formula. You can just smell the quadratic wafting in the air. Which way do you want to take things? People like to have their t squared positive.
Yes.
I do too. So instead of minus 10t, it's going to come across and become plus 10t minus 1,000. Well, Steve might be right. He's thinking that there are factors of 1,000, so multiply to give you 1,000, but add or subtract to give you 10.
Seems like the numbers are going.
It does, doesn't it? And when I give you the final answer, you go, okay, but you'll never in a million years guess that those two numbers together multiply to give you 1,000. Do you have a sort of a strategy for finding those numbers, Steve? Just sort of think and hope it comes in your head? Well, I have one too. It involves the quadratic formula. Minus 10 plus or minus square root b squared is 10 squared minus 4 times a, which is 1, times c, which is, now does it matter if it's minus 1,000?
Yeah.
It matters huge. Huge. only allowed to square root that up. It's a perfect square. So what, like there's like maybe 6 possible questions?
Well, we have to just leave it like that.
Oh yeah, I guess.
That's the exact factor.
Yes, I know. You pull out. Yeah, okay, I know. So it's gonna be like 3 root 3 or something or other. Yeah, I got you. So minus 4 times 1 is minus 4 times 1,000 is going to be? In my world, I don't want 3 root 2 seconds. I don't actually know that number. Those are your 2 numbers that do add or subtract to give you 10, 27 and 37. Did you find them? Yeah. Yeah. So, this means that Fred and Barney collide when? After how long? After 27 seconds. What's with the minus 37? Does it mean anything? Excuse me, anything at all?
Going backwards.
It's sort of as if they were going backwards somehow, but yeah, it doesn't make a lot of sense. Yeah, oh, that's how fast they go. Yeah, it doesn't work, doesn't matter. Okay, so let's just go back and look at the strategy there. I just plugged it in. I would be minus 10, minus 64 all over 2.
Oh, yeah, sorry.
Right? So what did we do here? Basically, it boils down to the crash occurs when their positions are the same. I set Fred's initial position to 0. I set Barney's initial position to plus 1,000, and then I determined on a formula. I derived a formula for the position of both of them, and then the key idea is the simplest one to write. The position of Fred is equal to position of Barney when the crash occurs, and then I plugged in, and then I solved from there. I'm going to let you work on the next one in groups. See how you do.
You want to answer those 2 that I didn't get?
Sure. I'll give you a little bit of a hint here. For example, 13, and then I'll let you go. Jack is running at 6 meters per second to catch a bus. He's running at a constant speed. V bar equals 6. He sees it start to move when he is 20 meters away. So that distance there is 20 meters. The bus accelerates at 1 meter per second squared. So it's going slower than him at the start.
Overtake it means like catch it.
Will he catch it? Will Jack get to the bus before the bus is going? Because how long does it take before the bus is going faster than Jack? 6 seconds, right?
You better be looking.
He's going 6 meters per second. But the bus is only going 1 meter per second, and then 2 meters per second, and then 3 meters per second. It's going to be close, isn't it? But he's got less than 6 seconds to catch it, right? Okay. Find a partner, find a group, solve. Again, you have to set up a position sort of timeline or position number line, right? So this is position 0. I did it in blue before. This is position plus 20, right? Position Jack is equal to 0 plus displacement of Jack. And position bus is equal to 20 plus displacement of bus. Is that enough? Oh, okay. So the next step is position Jack, PJ, is equal to 0 plus its displacement Jack. Jack is traveling at a constant 6. So it's V bar T, position Jack is equal to 6T, is it not?
Wait, how do you do that?
Jack's position, he's going at a constant 6 meters per second. So every second he travels 6 meters, right? So it's 6 times T. 2 seconds he's gone 12 meters. 3 seconds he's gone 18 meters. 4 seconds he's gone 24 meters. So the position of Jack is 6 times T. Is that enough? Look back at the example. Right? You got to find the position of the bus. Go ahead. No question? Here's what I'm going to do. I'm going to give you the answer, and then I've got a couple people I need to see before the end of the day. Okay? I've heard a few people get, it sounds like some of you are getting it. I've been quietly doing it up here if you've been watching up top. Let's go back in time a little bit and see what I did. Position Jack is 6 times T. We've established that already, I think, right? The position of the bus is equal to the initial position of 20 plus the displacement of the bus. So that's 20 plus D equals VIT plus a half AT squared, or 20 plus the initial velocity of 0, 1/2 of 1T squared, or 20 plus 0.5 T squared. And I heard a couple groups say that, and it sounded like you got that far. Jack catches the bus when Jack's position and the bus's position are the same, which occurs when position Jack is equal to position bus. So you set them equal to each other. 6T is equal to 20 plus 0.5 T squared. Bring the 6 to the other side, it becomes negative. Rearrange it so that the T squared is out front. Cheer because it's the quadratic formula. And after you plug it all in, you eventually discover that
Jack doesn't catch the bus.
bingo. How do you know Jack doesn't catch the bus? Because the 0 doesn't exist. In other words, there is no time when the positions are the same. Therefore, Jack is walking.
We figured there's a little variable there that you might steal a bike.
Or the bus driver might actually slow down.
Red light.
It has to happen between 3 and 6 seconds. Did you know that too? How did I figure that out?
Because he doesn't reach you until 20 meters in.
Until at least, yeah, he's only gone 18 meters after 3 seconds, right?
That's all I was trying to figure it out. If I could figure it out before you can.
You were trying to do the guess and check again, weren't you?
I was like writing out the positions.
Does that, but that only works for the integer values though,
Yeah, I
right?
figured out that he's never getting past the
Oh, is that right? Just by doing the integer versions?
Yeah.
Okay.
If you look at the time, yeah.
Yeah. I'm telling you, there will be a Jack catching the bus question on the test. There's only really 2 ways I can give it to you, right? It can either be this one going this way and this one going this way, or I guess it could be this one going this way and this one going this way. I guess it could be, if you think this is any different, right? This one's ugly just because they're both going negative, but you could, or just